the thing about hardware is when you have a bug in the design, every time you make more of them, the bugs multiply. and they're bugs that usually you can't.
I struggle to imagine how far you could evolve independently without having some sort of like common understanding.
We have abstract boxes, and here we put the CPU, here we put this mic, and here we put this camera sensor. But they are
like the classic example is the first iPhone, like functional iPhone, was a PCB about this big. It was like 2 by 2 feet. So yeah, I believe last week we had this question of pulling in cameras and microphones, and we wanted to get the audio moth pulled in. I feel like maybe the end of that thread was availability of components on the audio moth design, because we did find the schematic.
Yeah, but do we need the audio moth? Like, we can just take the mic and the camera, right?
Yeah, that's gonna be my question. How much sophistication is in the audio moth that we don't like? What does it do? I don't even quite understand it. Also, I'm thinking really about digital audio, so that probably doesn't help. But we want to, I guess, is the goal that we would be able to record a WAV file and then download it over a cell modem, and that's it? Or are we talking about processing it and doing something intelligent on board?
Just the recording. You can send it remotely and they can do remote processing. Let's stop with that.
There is also, there are many approaches that could be had here. So the one approach is to kind of like monolithically converge on a design. Oh my goodness! If you can hear background noise from my neighbor, I apologize. Okay. When I stop talking, I'll go get AirPods that fix that. So we could monolithically like converge on a robot and build it, or we could kind of have subsystems. So like the thing that hasn't been built yet is a mechanical design, which I think would help with the momentum. And that mechanical design could be designed around a motherboard PCBA that maybe we don't have yet, but there would be at least provision for it. And this way we would, there'd be kind of two verticals then. There'd be the actual hardware, the mechanical hardware and all of the main components, but then there'd also be the motherboard PCBA, and they could merge later. That is an approach. I mean, how do people feel about just sticking with one monolithic push versus having kind of like subsystems? They evolve a little bit independently, and then there'll be an integration point.
I struggle to imagine how far you could evolve independently without having some sort of like common understanding. Like, you can't go very far designing. Well, I don't know. I guess it depends on how big the placeholders are, but I think it sounds hard to do the components individually to me.
At the same time, if I don't have experience in PCB design, but so far what we've done is the high-level identification of high-level components. So we haven't decided which component exactly to put in each component box, basically. So is that the kind of modularity we are talking about? Is that we have a kind of abstract boxes, and here we put the CPU, here we put this mic, and here we put this camera sensor. But they are we can change them later. Is that the level of modularity we're talking about here?
I'm not referring to modularity. This is just sort of a canonical product development process where, like the classic example is the first iPhone, like functional iPhone, was a PCB about this big. It was like 2 by 2 feet almost. And like the display like was one area of the board like glued on, you know, like the display was like that was the size of the phone was stuck on the PCB that was like this giant floor tile. And that's a very, very, very traditional approach. Common approach is you like build the system in a development board form factor that's non-form factor to the end product. And this is in this particular design, the example of that could be like, you know, the cameras are here, the audio whatever is here, motor drivers are here, and it's like a board that we can be really, really lazy about how it's laid out positionally, and that could be kind of an independent effort. Eventually, that board has to work inside of this other part of the product, and then the board is subject to these spatial constraints, and you shrink it down. But that usually happens after. What we're doing now is everything at once, which is also an approach, especially for a design as simple as this. But you know, it just depends kind of how people want to do stuff.
I think we should optimize for momentum, but I'm not sure what approach gives us that better.
There is one thing that things like the iPhone, one of the reasons also why they don't shrink it first is just because it's an optimization. Okay, and usually we want to delay optimization. They have a lot of challenges to solve at first, and also is to have some hardware platform so that the hardware can move ahead in parallel, right? Okay. Especially operating systems and stuff like that take really a lot of time. Okay, so my understanding is that this is the kind of constraints that they are facing, and they are on a hard schedule. But for us, all that is quite different as well, right?
Yeah,
I mean,
like
no
I guess.
schedule and
Yeah, I think maybe there is an argument for a small team where like the EVM board isn't as valuable, because you are correct. One of the main reasons for the EVM board is just to make sure that the system can work at all before it's subject to these often cumbersome constraints, and that unblocks, you know, the firmware team and software team to then do their thing, because they can start developing on the actual hardware and testing on the actual hardware and not just the simulator anymore. But that way, because like you can spend literally years like integrating the hardware into the form factor. So it's like if you have a big board that runs the same processor, the firmware people can do their job. So that's the constraint. But maybe that's not a constraint here, especially because we're largely using little EVM boards that are off the shelf. Like, I mean, we have identified the mission and the components that are needed, right? It needs eyes, ears, and then 2 motor drivers. It's kind of like
and communications
and comms. I mean, who would want to kind of work on the software side of the robot? Like, would it be valuable to have off the shelf breadboards not on the robot to start working on the software alone?
For me, that's one question I wanted to ask in one of the sessions. Maybe this one is: do we have a kind of convergence at least on the CPU or the MCU or CPU, so that people may be more inclined to software can maybe get one, okay, and also start looking at the tool chains and everything involved. Okay? For example, I have ESP32s that we were talking about, including ESP32 CAM and so on. But you know, they are all slightly different, so choosing which one we would use would help me maybe do some learning in parallel and practice.
Yeah, I think that would be helpful too, to sort of be able to have a breadboard stage to kind of see how these components interact together, because we're doing so much learning on the fly about how to integrate those systems. Like, especially if most of the rovers that people have been working with have been Raspberry Pi based, this moving to like a microcontroller is going to be a pretty big shift. I think it acts somewhat similarly to like my first one, but like I think we're talking about using components that are much more functional, and even just knowing how to do communications with a microcontroller is kind of an open. I don't quite visualize exactly how that's going to be, because it was really cumbersome with mine, but I was working under even more severe constraints. So, but we would, yeah, if we were working on the same hardware that I was working with, which is a base Arduino, it would be a massive lift to try to interact with anything.
And at the same time, personally, I'd like to still see and maybe participate into everything around the PCB. Okay? I think that's a great opportunity to. Apparently, the kind of PCB we're talking about is relatively simple. Okay, as you mentioned, Joshua, and so that would be a great experience. And also, sometimes it's good to have some naive eyes, on a project to naive, or should I say, candid eyes on a project to for sake of discussion.
Yeah. So maybe this session, like, maybe we could try to close out the final component selection so that we could talk about ordering. Everybody has a set of components, at least for the one-on-one development purposes, such as like, can we run Zephyr on the Lizard Brain? Like, running Zephyr on the Lizard Brain, I think, would be an excellent entry point kind of a thing to figure out what it looks like. Where was that bill of materials? Okay, maybe we should just stick with the Excel draw, because we're all there already.
As long as we don't lose it, we're doing okay.
Yeah.
I have one comment. We have to be careful, because usually when you develop, you make changes in your design. But if we buy 6 of them, any change you make in the hardware design and the components, that you multiply the cost by 6. Just a comment. I have no.
Yes, the thing about hardware is, when you have a bug in the design, every time you make more of them, the bugs multiply. and they're bugs that usually you can't just like push an OTA to fix.
Yeah.
And yeah, that's why the stakes are so high. A lot of people at these large companies, they just like spend their days checking designs. Like, extraordinarily brilliant, educated, talented engineers, they spend their days checking, and it's because the cost of shipping, one of these phones or whatever with a bug is just so high. It's like incredible how high the cost of a bug is. Yeah, I cannot wait to see the teardown of the Vision Pro. By the way, it's gonna be so good. It's gonna be so complicated. I mean, it's gonna be wild in there. It's gonna be really interesting to see that thing. Okay, so I'm in the Excel draw. I was just gonna copy and paste the one set of components here, and then start filling these in with the actual part numbers. So
can you share the screen?
Yes. I'm picking out the window.
And when we're talking about part selection, are we starting? It kind of sounds like we're starting in a way middle out in that we're starting with the microcontroller and choosing the components out, but like we also have motors, solar panels. I don't know, or like the integrated battery solar thing. We haven't really
You
touched on
shared
power.
the StreamYard window, Jasha.
Yeah, but I can go over here, right?
Okay.
I'm just on the MacBook. I am.
Okay. Okay.
Oh, is this the right?
This is older. Yes.
I've
I'm
pasted
alone.
it in
It's this
the.
one.
Good.
Yeah.
Okay. Right. Yeah. I think to the point. It's we have a mission, so now we know kind of like in theory, we know at a ground level what is required, and that way we've tried to cover as many of the unknowns as possible. So now that we have a mission that governs the components that are required, but then with regards to like what components govern each other, that is a completely open architectural question.
Right.
And I would say like the thing about the lizard brain, that is the component that is kind of the central component in the design. And a lot of the other components may or may not flow down from them. So even in this motor controller kind of question mark, we can define this bus, like this interface, and what that component is. There's just so many options. I would say this is kind of like this component selection flows down from the host MCU, just because the host MCU is such a critical component for this project, because like developer friendliness and availability is key.
Yeah, but the interfaces coming off of that are gonna, like, there aren't that many options, right? It's gonna be an SPI or I2C bus if it's like something sophisticated, or it's gonna be a GPIO or PWM type interface, right? And like any microcontroller can do that. Like what?
Of course,
Yeah.
of course. That's part of my point. Is it's like it doesn't particularly matter what micros used. That said, that there is especially in design like this, we might even have this issue already where we have a pin shortage.
Right.
So we might have to put a IO expander in the design, or a MUX or some other component to give us more pins.
Right.
But yeah, because if we don't want to use a pin expander, we could use a different chip. It's got more pins, but then that has tool chain implications and ease of use implications that may not be desirable at this time.
Right.
So,
because we would like to stick to something close to off the shelf and easy to breadboard with, maybe, and yeah, it's certainly easy to find. There were some questions in the Discord over the weekend too about just like, well, how open is this, and are we planning to build a lot of them? And making part selection easy does seem like a priority.
Yeah.
Also, we don't have access to esoteric hardware anyway, so I don't know how we would work ourselves into back ourselves into a corner, so choosing something sophisticated, because where would we get it from?
Yeah, like the cellular modem, I do think for that that kind of criteria, like the Blues note card is a downside because it's a single source part, which they're doing a good job, but who knows? Maybe a company will get acquired or whoever. Like it's like an example of a vendor, who knows? And then like Anuraj had the other EVM where you're a bit more in control of your own destiny, but that does have like a time to market and fiddliness implications.
What does the interface implication look like? Like, is it still just, well, we have our entire rover and we're connecting to this black box communication module via I2C, or does it need to be integrated?
No, that's kind of the beauty of it. You just send it JSON. You literally send it JSON messages.
But if we ended up having to work with something else, would that also be true, or it would completely wreck everything?
We can completely define that. If we're in control of the modem, like ideally the firmware is designed in a way that makes it modular, where the firmware will have a modem object that you just pass messages to, and then you just swap out drivers.
Right. I'm trying to understand. Yeah, the expense of swapping out that component is, if the interface is kind of the same for all of them, then it doesn't really matter that much. We're not like setting up an assembly line and producing hundreds of these things. So yet.
But yeah, I would say like, yeah, we should just commit to a host MCU, and things will flow from there. I mean, that'll be a good starting place. Like, I mean, I feel like we've determined that we need to have a low power host MCU of some flavor in order for the system to be able to sustainably deal with power constraints.
Do we need Wi-Fi or ESP on the lizard brain?
It's a good question. I don't know. Do we? I don't know.
What was the question? I didn't hear that.
So ESP basically brings in the Wi-Fi, right? Wi-Fi
and Bluetooth.
Oh,
but
that's a built-in
you get
component.
that for free. Yeah, I mean, you don't have to use the radios. Like, it's just nice. It's a thing that comes for free.
I think we would definitely be helpful in development to be able to use Wi-Fi as opposed to like paying per byte for cell phone.
I mean, but Arnold, are you saying like it would be good to get rid of that constraint to open up the component selection to like STM or Atmel or whoever?
Yes, like what would be the use case? Because that radio will consume some more power, right? If we just have the micro without the Wi-Fi radio,
you don't have to turn the radio on.
Less power.
You don't have to turn the radio on. Yeah, it's just there. Like, you don't have to use it. It's on the silicon.
Yeah, like I'm okay with the ESP.
The big thing is if we want to use like Zephyr, and I know Zephyr has limited.
So ESP will have like less support. They just started it last year using Zephyr, so
yeah, I know.
Many of the drivers might not be like ported to ESP.
Or maybe because they just started, it'll all be fresh and new code. It works better.
Well, the FreeRTOS code base is much more mature, so all the bugs and they are like it has been found out, and we will get answers if we have some problems with FreeRTOS on the forums or somewhere else. So it has been there for almost a decade, right?
Yeah, I mean so that's what I'm getting at, is like if we want to use the ESP IDF, that's very mature. And yeah, that's very nice. The downside of the ESP IDF is that is heavily tied to the specific chip. So like if we were to use Zephyr, there's a lot more flexibility to move hosts down the road. Have you brought up Zephyr on the Espressif Tensilica stuff on Rush?
No. I've done it on some other small MCUs, but not on the ESPs.
Yeah. Do I have an ESP32?
And like this Zephyr's like build system and stuff is like a little more steeper. Learning curve is steeper than FreeRTOS.
This is okay. This is almost 2 years ago. Oh, and this is just the ESP32. This isn't the S1. Here, let's look at her S3. Nope. I'm just searching in the open PRs just to see if it's like people are actively moving it. Interesting. So that this is like an open question, kind of, is the takeaway. Is it worth it to go to Zephyr on the expressive target versus just using ESP-IDF? Is everybody here know what ESP-IDF is, just to make sure we're on the same page? Yes. So ESP-IDF that stands for ESP Integrated Development Framework, and this is a framework provided by Espressif to use their chips, and it's very widely used since their chips are very widely used in a lot of applications. It's based on FreeRTOS. So under the hood, they provide a FreeRTOS kernel, so you can do multi-threaded stuff out of the box really easily. It supports all of the chip's peripherals. It has all the like HAL drivers and everything sorted out to use all the features of the chip. And yeah, that's pretty much it. So it's like you buy their chip, and then they have this framework that you can use to develop for the chip.
So they're providing their own software stack to make it as easy and compatible as possible. So if we try to use someone else's stack that's more general, may or may not work as well.
It would require work to port it. Like there'd be work to port the firmware to another thing. The whole point of Zephyr is it's very much like there is a like Zephyr OS layer, and then they have drivers, and they have a pretty good way of like making the hardware interface layer a bit more modular, just architecturally. So it's like you can run Zephyr literally on the same chip that the Raspberry Pi is using, or all the way down to a little tiny micro like this, and it supports all of the peripherals and things. I guess in that way, maybe this is I'm sure somebody would take issue with me saying this, but I would liken Zephyr to Arduino in terms of its objective and usability and flexibility between targets. With that said, Zephyr is way more powerful and mature because it's really a fully featured RTOS. It's not just kind of like a framework that, because the Arduino framework is just, it makes it really easy to manage libraries and compile for different targets. That's like only a couple things that the Zephyr project is trying to do. So yeah, that's a decision that would have to be made if we want to go one way or another. I mean,
what's the quickest way to find out what would work for us and what wouldn't?
I mean, either will work. Well, let me put it this way: it's guaranteed that the ESP-IDF will work, 100%. That will work just fine. The Zephyr stuff is an open question.
It's something we can do in parallel. I have an ESP32 and well, first there is a question: is that how many ESP32 kinds are there? Because I have ESP32 CAM and ESP32 DevKit something, version 4, I think. And are there the same ESP32 MCU?
Yeah.
I'm sorry, I didn't check.
What's here? Yeah, no. So this is actually a great question. Let's see. This is the IDF support. I'm not. Am I sharing anymore? I don't think I am. Let me reshare.
No.
So Espressif has several different models of the ESP32. And the thing that is very frustrating is they don't necessarily, it's not like the S2 versus the S3 is just a new version of the old one. The S2 and the S3, like those two chips specifically, have some differences in the silicon that like there's some stuff in the S2 that is not in the S3 and the other way around. So they're all kind of different, which makes it very annoying, depending on how nitty-gritty you're getting down into all of the features of the chip.
Oh.
The biggest difference, though, between the S and the C series is that the S series is based off of the 10 silica architecture. The other is based off of RISC-V. So the C series is a RISC-V target, and the S series is a 10 silica target. Which that's not something that you're thinking about when you're like writing the code. But in terms of like what the actual silicon is in the licensing, that's the difference. So
I think S2 and S3 are also dual core. And the C3 is a single core.
It is. So they're all very different. Like the ESP32 is different from the ESP32 S2. Is different from the S3. Is different from the C6. They're all specifically different. So we have to pick one. That's a very important thing.
And is it possible that the distinction doesn't matter to us at the level that we're working at here?
Wow. Great website. That's not encouraged.
Look, they're not web developers,
website, right?
okay?
This is it's literally Drupal. Drupal. Oh wow. Okay.
Drupal's still around?
Yeah.
That's adorable.
Evidently not in a big way. Okay. Yeah, I don't know if that's sort of a telling. I don't know. They're very active on their repos and stuff, but it's anyway. So we have to commit to a specific chip because there are consequential differences between them.
Yes.
What's cheaper?
They're, for all intents and purposes, the same price. Yeah, you're really talking about, especially the volumes we're talking about, it's like $3.50 versus $2.80. Like, I literally just bought some this morning.
Well, what about, okay, so if we wanted a development kit to like try out, like, hey, is Zephyr going to work, etc., what could I buy right now and have shipped via Amazon or whatever and have this week?
The C series is pretty fresh still, so the S stuff is all out there. Yeah, this guy, or this one, depending on if you want the chip antenna or not. Yeah, it's like $3, pretty cheap stuff. It's available. Oh, we would want the room. Yeah, we wouldn't here. This project does not want that part. That would be a problem. This is what you'd want. The room is easier to solder, is why. The mini is very problematic. It can be very problematic to solder. So you want this one.
Oh, we definitely want it to be easy for us to use.
The usability, I mean, there's no. It's really just the assembly. Like if we want to use a cheap assembly house,
yeah,
it should be easy for them to make.
Or we want to assemble it ourselves.
Or with this package, you could easily do that. You could very easily hand assemble this package. But yeah, as you can see, this chip is very available, and it's not that expensive. It's $3 to $4.
Mm-hmm.
So what's the difference? You said you showed ESP32C and S, and what is the room? The room is another kind still.
Oh, sorry. Here, let me.
Sorry.
So yeah, no, it's a great question. So the ESP32 S3 refers to the actual semiconductor, like the chip. The room and the mini are modules.
Okay, so it's one level higher, so something bigger.
So this is
Yeah,
the
it's the
actual chip.
packaged version.
Like if so,
Okay.
this is here. You can see this is without the can on top. So like the little module that we're looking at, there's the actual chip inside of it, and then a couple little support components. Yeah. And then the whole reason for this is this one has an FCC ID, so this is already pre-certified, ready to go. But like this little module, it's a module containing the chip, and then like this is the actual chip. And we can also use just the actual raw chip, especially if we're not going to use the radio. But buying the module is nice because it's easy to solder, as we discussed. Because this is a lot. These big pins on the edge are a lot easier to solder than these pads. These are a bit more challenging to deal with.
Yeah, thank you. And so inside the room, there can be different kinds of ESP. It can be an ESP S or C, depending on the room.
Yes.
And
exactly.
And I don't see the. I'm looking at the dev kit I have, okay, and they say it's an ESP32 room 32, but I don't find which chip is inside. Is there, even looking at what is written on the room, is there something I'm missing?
Well, so the ESP32C6, that's the chip inside of this module in the can.
Okay.
And then the mini, it just refers to, this is the module's form factor. And the difference between the mini and the room is the mini, you notice how there's no pins on the edge? So see this one down here, there's pins on the edge? On the mini, the pins are on the bottom side underneath.
Oh, okay.
Yeah. Just so you can see. I'm sure okay. See how the pins are on the bottom side underneath? That is really hard to assemble. And then when there's a defect, when you try to x-ray it and then the can is in front of it, so then like the x-ray gets blocked by the can, it's a whole these are not worth it for this project. It's not like we don't have the room. So the room with the stuff on the edge is better instead of this one that has all the pins below. It looks like that.
Okay, thank you.
Okay, so I just dropped a component off of Amazon for $20. How much of the components there would match something similar to what we might use and could give us a head start on figuring out the development environment and the software side? Did we just lose Joshua? I'll share what I have.
So that thing that you got, yeah.
That's that one.
Correct. This is a long time ago in the Discord. I sent a photo of like the MVP. So this is that.
Is that that looks exactly like this? Is it the same chip? S3?
Is this a complete?
Yeah, no, this is the S3 room.
Yeah.
Okay. So this is exactly that part.
Okay.
Yeah. Yeah. So it's cheap and available.
All the electronics we need.
Well, if we look at the system block diagram, we'll see what is soldered onto this little board here. So that board includes this chip, this camera, and a little bit of power conversion off of USB. That's it. But that's a lot of stuff to try out initially. We canceled the second camera, right? Second camera is not part of the system for now. So yeah, I would suggest, I mean, that's kind of the chip of our time. It also has better power consumption characteristics for like, it's it's not the best at low power, but it's better than the C6. And there's that EVM that we have the link for that everybody can get and play with. Does that make sense?
Yeah, I like it.
Yes.
Available. Yeah, let me just check. Let me make sure this part number is. You also have to keep in mind that these digits on the end, the N8, R8, refers to the amount of flash. Because, Eric, to your point, the modules, there's also different variants within the same module. So the N refers to the amount of flash, and the R refers to the amount of RAM that they add a separate chip inside the module.
I see.
But like 8, yeah. So 8 megabytes of flash, and if we want to have RAM, we get more RAM. But I would suggest, I think the N8 is probably a reasonable choice because the SRAM one, the N8 R8 uses up more pins inside the module, so we have fewer pins. Let's see here. So this part is selected.
Wait, so and this is this development kit was -1. What is that? That doesn't fit that part. It says it has 8 megabytes of RAM, but I don't know.
Yeah, they so if you look on the can, this is the N8R8. I'm actually looking at the board here. So this is the N8R8. So this has 8 megabytes of SRAM as well. Which if we want to, okay, if that's the available EVM, just to keep things consistent, and also the price isn't much different, right? So there's the N8. It's 40 cents more, which is, I don't know that we care about that. The only downside with the one with the SRAM is it can mess up, it can interfere with some of the pins. But in terms of it being available in this little off-the-shelf dev board, maybe that's okay.
Well, this is a good way to find out. Start building with this and then see where it falls apart.
Yep. Okay, so this is the lizard brain. That part's selected.
Great.
And then, yeah, like a great question that somebody could answer is, what's the status of Zephyr running on this target?
Yes. Yep.
Zephyr versus ESP IDF.
Cool. Okay, so how do we power this thing?
Okay, so let's see. I'd honestly hold off on digging into that because that's a long conversation, which could potentially be. And I only say that because like it depends. Like there's a lot of different ways that this can look, the power stage and this one. But yeah, this is what I would suggest because we're trying to have people try out stuff. So I would suggest focusing on some of these other parts first. So like that, all of this part of the system is available and picked. Because the power stuff right now, you can just power it over USB and you're fine. But this is almost like an entire subsystem that could be designed independently. Because at the end of the day, this just needs a 3.3 volt rail. That's it.
Right.
So as long as it has a 3.3 volt rail, it's happy. here. We can just actually just write that in. We're also kind of, usually this diagram that doesn't specifically talk about parts, this is kind of a higher level, and then this will get more nitty gritty. So we might actually add more arrows and things. It's really kind of a different diagram because this is showing individual component level what the connections are.
Okay, so
this module, this module does have a SD card on the back as well. So it includes both of these. We have a schematic for this, right?
It also has an LED.
Well, it has 4 LED. Actually, it has 5 LEDs on the board. One of which is a RGB LED. Oh, this is not the right one. Wow, this is... Yeah, this is the correct part. Here, I'm going to paste this in the thread.
Does it have the schematic too?
Is there a schematic? What even is it? Oh, they have like the data sheets for all of the components? Is there a schematic?
No, I was just asking. Does it have?
Yeah, that's what I'm asking. I don't know. Whoops. This is that's right. The CH343 is the USB to serial converter. Yeah, we really need a schematic. That would help a lot.
Maybe search it on Google directly.
Okay. Wow. Okay. Super starter kit. Okay. View. That's the wrong one. S3. Oh, okay. Room board view. Download. Okay. If I download, is it just going to give me a zip of the repo? Yeah. It's just giving. It's just. Whoa. 100 megabytes. 200 megabytes. Wow. This is heavy. Oh, that's nice. Okay, SPBY. Yeah, this is literally the repo, so that's not very helpful. I think this is like, why are we spending time on this? Having the schematic of the board will be very helpful because it will show us the connections that they're making to the camera and the connections that they're making to the SD card. So if we know exactly what that is, it de-risks us building our own board. Anand, are you looking? I cannot find the schematic. Like, where's the schematic for this thing? This is crazy. Freenode schematic. Oops. I think they just don't.
Yeah, maybe they don't release it.
Oh, okay. So we got a Reddit thread going. Okay, somebody's like, oh, I gotta know where it is. Okay, I went to the page and I see the picture, but where is... Where is the? Okay, this is potentially a trap. I mean, this means we will have to spend some cycles, just pinning out where things are, which won't take a lot of time, but it's just very annoying. It's kind of lame. It's literally only like 20 pins, so maybe we can just tone it out. I can do that. I'm happy to do that. But that's really lame. Why can't they just give us a schematic? Okay, well, I'm happy to generate a schematic of this if we have to, because this picture is really all we need. And so if this is actually correct, I'm sure they didn't change their layout much between the 32 and the 32S3. Oh no, this is actually pretty different. This is because this has 1 versus 2.
Is there any way of sending them a letter asking them for the schematics and they send it back?
Absolutely, we could do that.
But is there anybody to send the letter to?
I mean, we could open up an issue on the repo. This is 3 weeks ago. It's like active. So there's people here. So does somebody want to send a support request or something? We could do that.
Pull request or an issue.
Yeah, because that board has these 3 key components in the system that we're after. And yeah, you're right, Brett. There's also this RGB LED. So that has a good portion of the required things. So that leaves us, we need to connect it to these things. The Blues modem has this EVM. So I would suggest we get, for people to play with.
I was just looking at that starter kit. It had both Wi-Fi, like a Wi-Fi modem, as well as like it's got more components that we need.
Yeah, so the easiest thing is to just get this, because this has the antennas soldered on, which is kind of nice. So this guy.
And quick connectors. Oh.
Yeah, and unfortunately, this FreeNov. I mean, does Adafruit make a ESP32 camera? Does she do that?
That's a good question. Don't think so. They are selling just the ESP32s though. Modules. They're reselling the N5 stack ones, which are like integrated camera and ESP32.
OV2640. Huh. She doesn't. That's Why?
It's almost like too much of a finished product.
It's interesting that why don't they? Maybe
Probably
it's
there is
because
already
they're.
yeah.
It's also. I mean, so it's funny. Like they have on their Git repo a data sheet that says confidential. So like usually you're not supposed to share these. Like, oh, you didn't see in the screen share. So yeah, like if you look in here, yeah. So like if you you look at the data sheet, it's confidential. Not supposed to have this, but maybe it's so long ago they don't care anymore. Yeah, it's interesting. I don't know why she doesn't sell that board. But anyway, for the note card, yeah, you could just, like, they do sell this dev kit that has everything. This is kind of overkill. And the only other thing that's kind of a downside is it has a adhesive patch antenna. This giant thing, which is fine, but it's annoying. But this is what that EVM looks like. They also make their own kind of mother. Oh, what I'm showing you is actually ESP32. I forgot. See, it's actually the espressive chip that they don't use the module. So this is there's a company that makes this board, and they actually, this little white puck over here is an antenna. So this is a chip antenna, and they have it plugged into the ESP instead of using the little ESP module, which is something that we could do, but there really isn't, in my opinion, a strong advantage in that. And the disadvantage is you don't have FCC anymore, and ideally, you don't want to make the FCC mad. We're also over time right now. I didn't even realize.
Oh, yes.
So maybe we could just.
We have 3 minutes. 3 minutes left.
Yeah, maybe we could just kind of go fast on a couple of things here. So, yeah, I would suggest.
Sorry, which note carrier was it that you were suggesting? A? It's got like a whole bunch of stuff on it. I can't figure out why.
Which one?
The note carrier for Blues Wire.
Are you want to share your screen?
Yeah, sure. How do I actually share it? Maybe someone else has to. There we go.
Yeah, so the long red thing is a LTE antenna. The little red thing is a GPS antenna. Mm-hmm. And then the rest is just connectors and USB power. That's it. There isn't a whole lot going on. It's just a carrier. The one thing that
right. So we breadboard from the ESP32 kit to this thing, which then connects to the actual modem. So you pop into it.
Yeah. One thing I left out that's actually kind of critical for this project. This board actually does have a solar charge controller on it, which is kind of interesting.
That is interesting.
The same thing with the big black one, the big long black one. It also has a solar charge controller on it. So there is a world in which we could just use this to get going. These schematics and designs are completely available for this no carrier board. So that's a good option to, like, if you want to try this one and use it, you can use their designs. They are totally open. You can do whatever you want with them. They're on GitHub. So that's the thing that's worth mentioning. If we do prototype on the bench with these, we could literally charge a battery off of it with a solar panel and go from there. There are constraints on that, though. It's looking for a specific solar panel and a specific battery voltage, but besides that, it's fine. Because it's like, let's say we want to run the DC motors off of a 7.4 volt battery. This will only accept a 1 in series, right? So 3.7 volt battery. And so the motors might not be as, we can just pick different motors. But in terms of having stuff on the bench for people to try out and make sure it works, this does provide more of the system on an eval board. So you would need to buy one of these and one of the note card, and you're done.
And how much is this?
This board is $25, and the note card.
The note card's the pricey part.
The note card is $60 for the global, which we would be using the global version.
Are we expecting to spend $100 on the more on the electronics of the Yakasaur?
I was hoping the Yakasaur, like the whole thing, would be less than $200. That was my thought. The biggest question mark in that equation is the Raspberry Pi. They say they are ramping their production now to like 4 or 6 times what they have been, so that their pricing is supposed to come back down to earth later this year. If you want to go with the Raspberry Pi, there are other options, but I would expect the single board computer to be about as much as the cellular modem. That's $60. So yeah, I think Yakasaur is like $200, $300 in that range.
Okay.
But isn't that interesting? It's like a pretty okay price considering what it is.
Yeah.
I don't know. I haven't figured
Actually,
out.
I think in the Excel sheet, I think there was some budget mention of 2,000 or something.
Oh yeah.
The Excel sheet we were
Yes.
Yeah, that's a lot.
But we can do a cost optimization later on too, right?
That's like a laptop. If the unit of measurement is a laptop, that's like you wouldn't leave a laptop rolling around the desert.
Or just throw an iPhone out there. Problem solved.
Actually, there is a project that uses smartphones as the brains. I think Google was doing something.
There's a number of projects that have done that. I mean, there really is something to be said for the smartphone approach. It's just it's very limiting because the only interface you have to the smartphone is the USB connector. That's it. You have USB.
When
OT.
there is a USB connector.
You have the audio as well.
On some phones.
On some phones, yeah.
I think I mentioned this before. The Rainforest Connection project. That was actually what they used initially. They used like a really old, crusty, I think like Samsung phone, and they plugged in like a beefed up microphone into that smartphone, and that was it. And they were like putting that in a little box and solar panel up a tree. That was a prototype. Makes a lot of sense. I mean, again, people spend a lot of time and effort making smartphones reliable, so there's something to be said for that.
Only question is, how do we use a smartphone to drive a motor?
Yeah. That's exactly the issue. Is like one.
No, forget about the connector. Imagine I could go inside and connect to some wire. Is there anything about a smartphone which says I can put out the power that a motor needs?
I'm sorry, there's a lot of loud noise. I hope it's not too bad. I'm sorry, Mayor. You were saying.
I was asking. Imagine I could open up the smartphone and connect to any wire inside that I wanted to. I'm asking if the smartphone includes circuitry suitable to drive a motor. Smartphone includes a battery.
There are small motors inside.
That's a loaded question.
I think doesn't the Taptic engine have some linear actuators inside?
Older smartphones used the acronym is ERM, eccentric rotating mass, which is what they call the pager motor. So it's literally a little DC motor with a weight on one side and just spin it, and that's how it vibrated. Almost every single phone vibration today comes from called LRA, which is spring mass solenoid system. So yeah, like all these phones have things to drive little effectively.
No, but I need enough power to the motor to move the Yakasaur.
So absolutely not. You would need an external motor controller, but there would definitely buses inside of the phone that you could connect to and potentially hack to then talk directly to the motor controller.
I mean, my preferred way to connect a smartphone is putting a photodiode on the screen and communicating like that.
Yeah, I mean, you can also connect to the smartphone over Bluetooth. I mean, a lot of products do that.
I'm saying that the cheap electronic way of doing it is, let's say I put a photo detector, and when I turn that pixel on, so it gets power. I don't need any sophisticated communication protocol. The electronics are very simple. A photodiode and a transistor.
I mean, the irony is that would actually be more expensive because you already have this. Let's say we're using the Espressif module. You already have a module that has Bluetooth for free. So adding that photodiode is more parts.
No, but what I'm saying is, if I want to have 20 outgoing wires or 50 outgoing wires, I can do that. Each wire that I add is one photodiode and one transistor. That's what I'm saying.
You could do that. I mean, that's certainly an approach. You could also make it really. It could be kind of stupid. Like maybe it's just that pixel drives the motor forward and backwards.
That is the next step. I have one pixel for motor forward, one for motor back. In other words, you can build from a circuitry perspective. I can have very simple circuitry to control the motor.
Yeah.
All of the brains is in the whatever, and the only part that's outside of the smartphone is the actual power switching. So if I have a power supply which knows how to deal with it, the minute the pixel goes on, the photodiode opens the switch, and you get power.
Yeah, I mean, it is kind of an interesting concept of like using the cell phone display as this sort of analog, effectively like keypad. It's a light sensitive keypad.
Yeah.
But I mean, there's this question of like the scalability of that.
You've got 1,000 pixels at least, maybe 1 million that you can access.
I've actually never had to. I've never intentionally sat down and been like, can I source 100 old crappy cell phones? Like, is that something you can just do? I would assume it is because they flow everywhere. But like, where do I do that? Do I just go on eBay and start buying old cell phones? Like, how do I get like if I want to have lots of crusty old Galaxy phones?
Yeah, and you want their batteries to be functional. That's the problem.
And you want them to work and not crash. But let's ask.
Cell phones are like impressively reliable. I mean, when you think about it, it's like incredibly reliable. And, they're like not as reliable as cars, but very reliable.
Samsung sells refurbished ones.
I mean, the next question is, would it be cheaper?
It's simpler because I just buy a smartphone, runs Android, so I don't care which one it is exactly, and I use it for controlling everything, and I get built-in image processing ability and even a camera if I want.
I mean, the thing that isn't simpler is you still have to have a lizard brain to manage power on this, like, because there's always this issue of like, okay, it's like because what we're doing is we're saying we have an off-the-shelf system that we air gap and build around in a cheaper way, which is interesting. But then if at any point there's a subsystem that has to exist outside of that, because it's like it gets more complicated to work around the phone in some way, that can easily consume the benefits. So it's like the smartphones are notoriously bad at battery life. So it's like then we have to have a way to turn the phone off and turn it back on, and then it has to have its own firmware, and then we're back to where we start. So I mean, it's actually, I think it's a great question. Like maybe the big brain should be an old smartphone. That could be really interesting. And then we talk to it over Bluetooth. I think it is.
Pi. And maybe we can also have it, wake on, audio, wake on USB. I don't know what these phones are capable of.
Yeah. For the cell connection though, there is I don't know. Like, okay, so the main issue, I don't know, has anybody here like done any Android development, like hardcore, like Android kernel development? Yeah.
But we can use one of these Linux kernel Pine phones, right? Then we just use normal Linux for development.
So it would be Debian? Wait, what do those run again?
Pine phones. I think they run some sort of.
Oh, the Pine 64 people. Yeah.
Okay, assorted T-Mobile smartphones, poor condition, for $150 on eBay. 23 of them. Okay, I gotta leave.
Interesting though, the big brain being a smartphone is very interesting. Is there anything?
Pine phone is $150.
Oh, that's a lot. Okay, so potentially a big brain smartphone. That could be really cool. Okay. Did we figure out the base? Maybe, okay, on Discord we could talk about actually buying some of these things, because then people could start playing with the firmware, and that would be a good side thing. I would suggest this for next week. We actually do a little bit of the mechanical stuff, because I think that's a momentum activity to actually have some hardware. Maybe. What do you think?
Yeah, let's do it.
Okay, cool. Next week will be the actual physical robot.
Cool. Talk to you later.
See you.
Yes. Thank you. Cheers.
Thank you.